recording? I am recording. Wonderful. Here I am. Okay, so today's lecture will do about half of this: GUIs, graphical user interfaces, and event-driven programs. So these standard classes in Java are provided through a few packages, java.awt and some of its sub-packages like awt.event and javax.swing. So the difference between these two main libraries: anything starting with Java dot, right? That's the Java library. That's considered essential Java, or, you know, very standard and accepted and widely used. Java X is considered standard because it's still, you know, developed and released by Oracle, but it's considered extended Java. So, you know, it's been tested, it works, but not everything out there is going to include this. And anyway, over time, what often happens, new features get implemented, introduced through the Java X library, and over time they might find themselves drifting into the Java library as they become more widely used. So that's what the difference between the two is. They're both Java, but one is core and one is, you know, more peripheral. There's also another class, set of classes called Java FX, which was supposed to replace these swing GUIs. I don't know, is it happening? Realistically, not many people are designing GUIs with Java these days. There's other languages, other mechanisms for doing it. The point of this, number one, let's see. With GUIs in an instructional setting, students feel like they're doing something real, right? It's way more interesting, right? Way more interesting and exciting to get something graphical to work as opposed to something that's text driven. And this helps keep people somewhat interested, okay? Number two, of course, you learn about inheritance, various graphical design properties. So you learn some Java stuff, but perhaps most importantly, about event-driven programming. Okay, so in a GUI, it'll be user clicks this or types that, and the application responds. Right? That's a neat thing to do. But all sorts of other event handling methods exist, or techniques, I should say. Let's not confuse with terms. Techniques exist in non-GUI uses. So this stuff with event handling, yeah, you use it for a lot of other stuff if you go on to do some serious Java programming. Okay, but if you learn it in the context of GUIs, even though, yeah, you probably won't really use GUIs in real life, sure, but you can learn about event handling, and that's useful, and it's a way of making it kind of fun, I hope. Okay, so if you're interested in this stuff, there's a whole bunch of tutorials on Oracle about how to use these swing components. I have them up in Blackboard at this time. So here, for example, the Java tutorials, you go here, using swing components, there's a whole bunch of stuff here. Okay, you can see on the side, there's lots. I'm in my lectures, I'm just giving you the tip of the iceberg. There's a whole lot more. All right, so let's get on to it. So number one, how Java GUIs work. Well, there's two kinds of objects that go into GUIs. Number one, top-level containers. Those are application windows. These top-level containers contain other components. They run as visible applications. So in my Connect 4 application, the frame that I ran everything in, that was the top-level container. The others are components. Those components can be stacked onto other objects, which could be either top-level containers or components. So for those of you who were paying attention when I designed my application, it basically looked like this. We had the one, right, the frame. This was the application window. The top level container. And on that top level container, attached first panel. All right, so a JPanel which was where things went. That JPanel, I attached a few other things, right? I attached a few other panels. So there was one at the top and one down below and a big one in the middle. Okay, so right here, other JPanels on top. And then in some of those, I had other components added. So in the one down below, for example, I had a start button or a cancel button and a start button, I believe was the layout of those. And start. And in the middle, I had a whole bunch of other panels, right? So these were my custom panels to show the various Connect 4 plays. 7, it's 7. So right, we had this 6x7 setup. So this is basically the stacking arrangement that I had within my application, within the Connect 4 application. Do some of these. I don't know, we'll make it look good enough, I guess. Okay, so the point is, this main application frame the TLC is the class that actually runs. I'll say, in my case. Okay, these other components do things within that application. Okay, so for example, in the Connect 4 application, if I clicked in a row, it would register that, oh, you want to move in that row, and it would make the make the game piece appear. If I click cancel, if I click start, something will happen within the game. Okay, so we have that. Now, every tree has what's called a containment hierarchy. So that tree of all the objects in a top-level container. So if we do this, let's look at how this is going to look for this particular case here. So I'm going to crunch this up a bit. Okay. If we have this, I start off with first my TLC. Whoop. There we go. TLC, and downstream of the TLC, there is a single big panel in purple. Downstream off of that, there are 3 other panels. Okay, downstream of this one, do it that way, I guess. There's 2 buttons. Whoop. Draw a second button here. Fine, let me try to overwrite that. Okay, 2 buttons, and down off this middle one, there are, whoop. I'll say times 42. Okay, because there's 42 of those little panels. So this is the tree, right? This is the tree that shows what's all on this application window. And it's a lot like the DOM tree for an HTML page. Remember, oh wait, that was 313, we talked about that. It's a lot like the way that things are laid out on a web page. Different components contain other components. So that's what we have. Now, one key point, number one, no object can be duplicated in the hierarchy. Even if it looks exactly the same as another object, you can't have 2 duplicate references in your containment hierarchy. That'll throw everything off and your window won't display right. Another thing, in most cases, only the last object contained in a particular portion of the container is visible, right? So basically, when you add components, they're going to cover up whatever's below it. So for example, this purple frame here covers up pretty much all of what's in the main window. These 3 panels that I add on top of the purple panel, they're going to cover up that space. And these 42 much smaller panels that I add onto the middle green panel, going to cover up that. Okay, and so on. Now buttons are unusual, well, depending on the component. So panels fill up the available space. That's what they're supposed to do. Buttons, depending on what all is going on, they often appear small. But if you're using a layout manager that forces them to expand to fill the available space, then they could fill up an entire panel. But if you just add a J button to a panel like we're doing here, then they're going to appear as small buttons. Okay, so that's it. Number one, for any GUI window, there's going to be a tree of components. The top level component is the application window, and then all the things are added on top of that, and generally components conceal whatever's below them. So you only see the top thing in the stack. So first thing, JFrame class. Your JFrame is your basic application window object. Has a few built-in features. Has a title bar, minimize, maximize, close buttons in the upper right. Has a small border, so you draw things in the middle, but you can still see the very edge of the JFrame. And it has what's called a content pane. The content pane is the area where you can add other components. A couple of quirks about JFrame. Number one, by default, it is not visible. So if you create a JFrame class in your application, you want to create a JFrame object and it doesn't appear, well, chances are it's because you have not made it visible. And the reason is, the idea for using a JFrame is you build all the content first, and then once the window is built, then you make it visible. That makes it show a little better without flickering. Also, shutting down. By default, a JFrame application does not end on the window close. So you click that close button in Eclipse, your application is still running merrily along. So you have to stop that. All right, so we're going to make a new class here. We will call it KFrame, I guess, because we're very creative. Okay, so KFrame will extend JFrame. And we're going to import our basic classes. So import java.awt, that'll do for now, and import javax.swing. So we got all that stuff. Eventually, we will need, what are we doing here? Oh, dot star. Okay, and ultimately, we're also going to need java.awt.event.star for our events that happen. Okay, so this is our JFrame. So let's make a constructor, very simple constructor for KFrame. So we'll do use some built-in JFrame methods. So this dot set title, we'll call it KFrame. This dot set size. We can use just a couple of numbers to do that. And another one, this dot set visible true. All right, we're going to make it visible. So I'll say separately, this should be last. Okay, so when we run this, let's actually create the thing too. KFrame KF equals new KFrame. Okay, we're going to do this. Oh, and one last thing. This dot set default close operation exit on close. Okay, that'll make sure that the application actually stops when we run it. So I run this, and boom, we get our little application window. Now, right now, it doesn't do anything. We've got this KFrame here, and when I close it out, then it closes it out. I can go look at my console just to verify, is everything shut down? Yep, I ran this KFrame application, and it's terminated. We're all done. Okay. So we have that. Other things, stuff we've covered, basic core methods, set default close operation, set title, set size, set visible. We did all those. You also have a few other things, set preferred size, set minimum size, set maximum size. These are methods, they mean what they say, right? So for example, if I set the minimum size as 100, 100, I will find it very difficult to scrunch my window down below that. Okay. This dot set minimum size 100. Do I need to do a dimension on it? Yeah, I do. Okay. So some of these take pairs of numbers, and some of them take dimension objects, which are objects that accept, a pair of numbers in a constructor. I'll do another one for set maximum size. Maximum size, I'll make it 1,000 to 1,000. So I can make it pretty big, but not insanely big. Okay, so let's run this. We'll see how it goes. Okay, so here, I'm going to shrink it down. And this is as small as I can make it. Right, so this is kind of neat. This is boom. I can't make it any smaller. I'm trying to scrunch it, but it won't go. Conversely, it doesn't obey the maximum size limitation, right? I mean, I'll try this again. this is half my screen, right? So this is going to be 800 pixels wide. Well, clearly I can make it 1,000 pixels. You know, it's like 1,600 pixels wide. So what you'll see, there are definitely some quirks in what aspects of minimum size, maximum size, preferred size. These will not always be observed. Okay, so set limits on window size. I'll mention not always enforced, as you will see. Okay. So again, a lot of this stuff with GUIs, there's a certain amount of trial and error until you get used to how they work. So yeah, that's part of the whole experience thing. Same thing, a lot of these other GUI objects like panels and other things, they use these same sizing operations, but their execution is definitely context dependent. So in some contexts, these size limits may be enforced, in other cases not. For an obvious one, right, if you make a panel, I'll mention many components will automatically fill up the available panel space no matter what. All right, so examples like a JPanel. A JPanel will always fill the available space. Likewise, a JButton, right, a clickable button will fill the available space in a grid layout. So what it is there are different contexts and there are always a whole bunch of rules going on about which rule should be enforced. So for example, if I have a minimum size, a maximum size, a preferred size, yeah, in some cases those will be enforced, but they have a priority level. And if something else with a higher priority level comes along, for example, saying, oh, I have one JPanel and that's all I'm adding to something, well, that JPanel needs to fill up the entire space. So the sizing constraints get ignored. Anyway, it's one of those things that some trial and error will go a long way towards figuring out what helps. Okay, JComponent, next thing. JComponents, they're an abstract superclass. What does abstract mean? In Java, abstract means you can't actually create objects of it. So you can't actually create a JComponent object. However, the JComponent class has many subclasses and you can make many, many objects of them. So things like panels, menu bars, labels, pop-up windows, all those are different kinds of JComponents. Also, JComponents are containers. That means they can hold other objects. Okay, so for example, you can add a J button to a JPanel and it will be contained within it. Okay, if you want to know more, here we go. We can look at JComponent class. Okay, so this one, again, is abstract. You can't do nothing with it. Here we go. Public abstract class JComponent. You can't make objects of it. It extends container, so it's a kind of container class, which means as far as Java is concerned, it can hold other things. So it can build this kind of tree hierarchy where you say one component holds another one. And it's also serializable. We'll talk about that, but that essentially means there's an easy way to convert it to a data sequence for things like input-output operations like saving to a hard drive. Okay. So this lecture, maybe not today, but over the course of the next day or two, we'll cover JPanel, JLabel, JMenuBar stuff, text fields, areas, JButtons. So these are just the basic elements. There are a whole lot more classes out there for more specialized purposes, but this is enough of the basics to get you going. Once you understand all these, using the other ones isn't a big headache. Okay, so first, JPanel. JPanel is a borderless window. So it doesn't have any edge around it, but it's a window that fills up the available space. Typically, when you want to use it is to directly add graphics to something. For example, you can't just draw on the content pane of a JFrame. You actually have to add a JPanel to the frame, and then you can draw on the JPanel. Other thing you can do with the JPanel, it can be a base for adding other components. So typical usage, you have a JPanel, you add it to the JFrame's content pane, then you can add some other JPanels on top of that base one and add components on top of them. Okay, so for example, you do this, just go ahead and type it in. So we'll give this guy a JPanel, JP base. Okay, and in our constructor, we'll start build the window. So we'll say
JP base equals new JPanel, and then this dot add JP base, and then JP base dot set background color dot red. Okay, so we'll make it appear red. So we create the new panel as an actual object, we add it to our window, to our frame, and then we set its background color to red. Ta-da! There it is, and now it's red. Hooray. Okay. Moving on. JPanel, basic stuff. Adding J components to a JFrame. So every JFrame has a container object called its content pane. In older code, you would have to reference that content pane object directly. So it was a container object. You would find its reference by calling for the JFrame something like container CP equals jf.getContentPane. So you call the getContentPane method on the JFrame, it would return you the reference of that content pane, and then you could add components to it. Nowadays, so for the last several years, you no longer have to do that. Now you can add components directly to the JFrame because it was bothering a lot of people. You'd have a lot of novice coders, they were trying to add components to the JFrame and didn't work, and they'd get upset and they'd go around and look on Google for a while and say, why do I have to do this nonsense with the content pane? Why doesn't Java just make it easy for me and let me add things directly to it? Well, yeah, eventually they got the message and they did that. Okay. Couple more things. So we'll do labels and I guess menu bars and text fields today. That'll be enough. We'll wrap up the rest on Friday. So JLabels. JLabels enable adding static text or images to a J component. So for example, I could have this JLabel, hey, and it will appear as that on my text. Or I could also create an image and add that. Okay, so we'll do a couple things here. We're gonna add some stuff. So first of all, in Paint, I'm gonna make my traditional sunny sky image. Let's see if I can shrink that down adequately. There we go. Boom, that's fine. Let's fill it with light blue. And we're gonna do another little circle up here in the corner. There we go. Okay, so we're gonna save this. And we'll save it to, we have to actually go up and save it to our workspace. Okay, so fall 2020, save it in the source folder, and there it is. So I'll save it as sunny day.png. Okay, and there it exists. So if I want to do this, as a JLabel, I can just do it with text. I can create a JLabel that has text, but much more interesting, okay, is I can save it this way. So I'm going to add, I'll even grab this. I'll grab the whole slug of text there. Okay, so over here, next thing, I'll give it a JLabel, JL IMG, okay, and I'm going to add an image. So I'll just do this to the base panel for now. So I'll just copy in the code. So from workspace directory, image icon is new image icon. This I'm going to do, it was instead sunnyday.png. Okay, I'll leave that question mark in there. That's fine. This is JLabel IMG, new JLabel, and I'm going to add it to JP base and JL IMG. Okay, so let's run this, see how it goes. Oh, there it is. Haha, how about that? Okay, so you can add an image to your stuff as well. Okay, if I wanted to, I could also do another one with text, but text is not nearly as fun. But if I wanted to, okay, I could do something like JLabel JLTXT. Okay, and I could do something like add a text JLabel. So JLTXT equals new JLabel
words go here. Okay, and then again, add it to JP base, add JL text. Okay, so that's how we do that. We create it with our constructor. We send along the text we want to be displayed, and then we just add it to our frame. So there it goes. Words go here. Now we'll, in a little bit, in the graphics lecture, we'll cover how to do fonts. So obviously it doesn't all have to be tiny like this. You can change the font as well. But that'll do for now. Let's do it, we'll put in a title. So do title, sunny day. There we go. Okay. So that's a simple bit on labels. So labels are static content. There's just text that doesn't change or images that don't change. But you can actually change them because changing what the label has doesn't affect that containment hierarchy. So anytime, I don't want to get in a whole thing on this. If you're changing something, some characteristic of a GUI component, that's not going to change the component hierarchy. But if you change the things that are in that tree, then yeah, you're going to have to reset that and to an extent, rebuild your window. Okay. Next thing, JMenu bar, JMenu, JMenu item. So these are again built-in feature to JFrames if you want to have a drop-down menu. So you don't actually add them. There's actually a method you can call that allows them to automatically be created. So this is JFrame's set JMenu bar. So what I'm going to do, I'm going to build some stuff in the menu. Okay, so I can have this JMenu bar JMB, JMenu JM, we'll call it JM1, JM2, and we'll have JMenu item JM1A, we'll call it JMI 1A, JMI 1B, JMI 2A, and JMI 2B. Okay, so we're going to create all these things. So the next thing will be building menu. Build a J menu. Okay, which is again something that's inherent to it. So I'll say JMB equals new J menu bar. Okay, and we'll say this dot add set J menu bar. Okay, that's a method that's built in, and then I can just send that one along. Okay, now in order to make this work, I have to add on all these other components to the J menu bar. So the J menu bar is the bar itself. See all these words here like file, edit, source, refactor, navigate? That's those, each of those things is a tab. That's a J menu item. The bar that they all exist on, that's the J menu bar. And then the things underneath, those are the J menu items. So to make this menu work, I first add the menu objects to the J menu bar, and then I add the J menu items to each J menu object. Okay, so I'll do a couple simple ones. I'll do J menu. It was just JM1 equals new J menu, and I'll give it a name. Let's call it colors. Oh, let's do it sky. We can do a couple different things for this later on. And what I would do, JMB.add JM1. Okay, likewise, JM2 was new J menu sun, and JMB.add JM2. Okay, so now I've added these two tabs to the bar. If I run it, they will appear. See, now I have a sky one and a sun one, but I don't have anything under them, so if I click on them, nothing happens. Well, we got to fix that. Okay, so next thing we're going to do, we'll add those J menu items. So we're going to do JMI1A equals new J menu item, and I'm going to give it two options. So the sky could be either blue or it could be new J menu item. I don't know, I guess gray. Okay, that's fine. So in that case, what do? I do JMB, JM1, add JMI1A 1A, and JM1 add JMI 1B. Likewise, I can do similar stuff for the sun. So the sun, it could either be yellow or, I don't know, let's make it orange as another one. Okay, and I'm going to add those to JM2. Let's replace all those ones with 2s. Okay, so I save this, now my menu is built. And fortunately, the nice thing about these menus is I don't have to do a whole lot of stuff around them, right? The options are right there. Now, if I wanted to do some interesting stuff, I'm going to do a little side thing. I'm just going to implement this so we can come back to it on Friday. So I'm going to do some event handling. So implements action listener. Okay, an action listener, you can actually register with these things. So I'm going to say, you know what? I'm going to hold off. I'm going to hold off on this. I don't want to. I thought about doing it now. I'll come back to it. That's fine. We'll do one more thing. We'll do JTextField and then JTextArea. So JTextField, there are a couple of different ways to do text fields in a basic Java GUI window. So one of them is a JTextField that's a single line of text. Okay, so it has two methods, set text and get text. Set text, you can write contents in the field. Get text, you can read what's in the field. And there's also a toggle for whether you want users to be able to change it or not. So by default, it's set to be true. You can edit it. Okay, and then anytime you'll press enter while you're in that field, it'll create an action event. So you can have in your window, type some text into the field, hit enter, and then it'll automatically get processed as an event. Now, JTextFields have sizes, but it's a little weird how the sizing works because it's not directly built around pixels. It's about what Java thinks an appropriate size is based on the text, based on the font size, based on the container size. So it's a little bit weird to get those text fields done. The best rule of thumb I can give you is that if you want the size to be appropriate, figure out what text it should hold, and then create it when it's holding that text, and it'll keep that size. Anyway, so let's go ahead. We'll do that. We'll do a JTextField. Okay, and we'll add it. So add a text field. So JTF equals new JTextField, and we'll give it the initial text. Text goes here. And then we'll add it to our window. So we'll say jpbase.add JTF. Okay, so again, once we run it, the text field will appear. There it is. Now you'll see it's a little bit weird in terms of how things are laid out. So the image got created big. The label for it appeared on a new line. This text field also appeared on a same line, but if we stretch it out, if we have enough space, it'll display things in different ways. So these GUI windows are inherently dynamic as far as how they're going to display content, right? It automatically does some of that resizing work for us. Okay. Anyway, get rid of you. Last thing then, we'll cover JTextAreas. So JTextArea is essentially multi-line text. So all the stuff that you can do with a JText field, you can do with a JTextArea. You can also include multiple lines of text. And there's an append method which you can use to add to what's already in the JTextAreas pane. If you're interested, if you want to have a scrollable JTextArea, like a window where you have a large article of text, yeah, I included a little blurb here about how to add scroll bars to a JTextArea. But for now, since that's kind of peripheral, we're just going to add the area. JTA for JTextArea. And we're going to add some letters here. So add a text area. So window, if you like. Say JTA equals new JTextArea. And we're going to add in some lines. So we're going to say 1 and then \n, 2 \n, and 3 \n, and then 4.
So add in 4 lines of text, and it'll automatically appear as such. Okay, so we run this. Oh, we didn't add it. We ought to add it. That'll help. JP base.add JTA. Okay. Now it's really weird there, right? It's really narrow. It only displays the size that we want to see. So if we want to do this, let's try to see if we can do something with a preferred size. JTA.set preferred size, and we'll do new dimension. What should we put? Let's do it, I don't know, 400 wide by 200 tall. Let's see how that goes. There. Now it's much bigger. Okay, things are a little strange, but that's okay. So if you want to control the size of these things, right, you can do it with the pixels, but then you also have to regulate based on the font, because if you have a big window and your font is tiny, it might look kind of silly. Okay, so same thing with JText field objects. Again, we can do this JTF.set preferred size. We can do the same thing, new dimension, I don't know, 400, 100, 450, I guess. It's fine. Do something like that. And there we have our 2 objects in the size that we want them to be, more or less. Okay. So that's quick stuff here. So key things that we've covered, right? Key things, key takeaways from this. JFrames are TLCs, top level containers. So they're application windows, and they have some quirks, that's fine. Other components can be added to the TLC or each other. Last component stacked is the one that's visible. And what else? Sizing and arrangement is, for now, a bit chaotic, right? But don't worry, we'll get to how you can arrange these things a little bit better on your window. Okay, so that's the key takeaways. That's the stuff for today. Tomorrow, we're going to go through more of this lecture. We'll see a couple more object types like JButton. I guess that's really the only one. And some colors, some layout managers for how you can arrange components like the box layout, flow layout, grid layout. And then we'll cover interfaces. Interfaces will be the rest, how you get objects to be ready to respond when the user interacts with the window. Okay, so this is our lecture. I guess I planned to end a little early, but it wasn't that early, so that's fine. It is what it is. Any questions on any of this stuff? I hope it all makes sense. Any questions?